In your last video, we talked about midpoints and how if we have a midpoint on a segment, then that tells us that we have equal segments. It divides us into two equal segments like we have with AB and BC. Okay, now this video, we're going to talk about a very similar concept, but that would be bisectors. Okay, first we'll start with an angle bisector. If we are given this angle, the whole big one, ABC, and then you've got kind of this line down the middle, BD. That's actually called a ray. It only continues in one direction. So you've got ray BD. Then if ray BD is the angle bisector of angle ABC, then that tells us that angle ABD is equal to angle DBC. On our diagram, we can put these kind of loops, these arcs inside our angle to show that they're the same. Just like with our segments, we were able to put those tick marks. Okay, now this is the same thing as saying angle ABC is congruent to angle DBC. Notice that when we use the congruent sign, we only use the angles. When we use the equal sign, we also add in there the measure because we're talking about the numerical value. Okay, now definition of a segment bisector. If we're given a segment with a line that goes right through basically a midpoint, a point on it, that if that is a segment bisector, then these two segments are equal. So if line XY is the segment bisector of segment AC, then the length of AB is equal to the length of BC. Again, that's the same as writing segment AB is congruent to segment BC. Okay, so notice like these conclusions for segment bisector and midpoint are exactly the same. We're just given a different piece of information. The only difference between the bisectors and midpoints and the angle bisector is that now we're looking at congruent angles versus congruent segments. So let's look at a couple examples of these bisector problems. Suppose that we are trying to solve for x given an angle bisector. So ray BD, that should be BD, is the angle bisector of angle ABC. Can we set up an equation to prove that x equals 30? Let's try it. We've got x, actually let me start with just what does it mean? We have an angle bisector which tells us that the measure of angle ABD is equal to the measure of angle DBC. So that would mean that if ABD is x and DBC is x over 2 plus 15, then we can set up our equation to say that x equals x over 2 plus 15. Now, if you're stuck here with this fraction, maybe try writing it as instead of x over 2, we've got 1/2 x. Okay, those mean the same thing. So now if I subtract that 1/2 x from both sides, I get 1 minus 1/2 is, again, just 1/2 x. Okay, and then how do I get rid of division? I multiply. So I get x equals 30. And that's that. Okay, so let's take a look at the next one. We are given that XY, line XY is the segment bisector of segment AC. Can we set up an equation to prove that x equals 2? So if we're given a segment bisector, that is going to tell us that the length of AB is equal to the length of BC. If AB is 5x plus 1, and BC is 2x plus 7, then we can set up an equation to say 5x plus 1 equals 2x plus 7. If we solve that, we can subtract 2x from both sides. That's our subtraction property of equality. We get 3x plus 1 equals 7. Subtract 1, 3x equals 6. And our division property of equality, we can divide by 3 to get x equals 2. And there we have it. All right, any questions you have, feel free to flag me down and ask. Hopefully you have a good understanding of these problems now.